Okay, question 9. So it says that Julius buys a washing machine. 20% VAT is added to the price of the washing machine. Julius then has to pay a total of £600. What's the price of the washing machine with no VAT? So if we say that the price of the washing machine plus the VAT is 600, and so the VAT is 20%, and of course the price of the washing machine is going to be 100%. So this is 120%. So we divide by 6, let's say. So if we divide by 6, we get 100, and then that equals 20%. And then so to get from 20% to 100%, we times by 5. So we get 100% here. And then if we times by 5, we get 500. So that means that without the VAT, the price is £500. Question 10, it says show that, and you have this here, can be, so it's expression, and it can be written in the form as follows, where A, B, C, and D are positive integers. Okay, so essentially you just want to expand the brackets. So let's start off with x plus 2, x plus 3. So I'm going to use my arrows for this one, and then this one here. So we get x squared plus 2x plus 3x plus 6. And then the one that we have left is x plus 1. I'll do it in a different color. So let me just do that. And then I'll do this one in a different color. So x plus 1 times all of this. 3x plus 6. So again, my trusted arrows, and I'll use a different color for the other arrows. So we'll get x cubed for this one, plus 2x squared plus 3x squared plus 6x, and then plus x squared plus 2x plus 3x plus 6. So if we add all of these up, we'll have x cubed. So we've got how many x squared? So 2, 5, 6. And then how many x? So we've got 6, 8, and then 11. And then we've only got plus 6. So that's our answer. Just write that out a little bit more neatly. 3. Question 11. It says the graph of y equals fx is drawn on the function, drawn on the grid. So this is a function. Write down the coordinates of the turning point. So the turning point, as we know, is literally where the gradient goes from being 0 and changes its charge, if you like. So that's where the gradient is equal to 0. So that would seem 1 and minus 3. 1 and minus 3. Write down estimates for the roots of fx equals 0. So where fx equals 0, so fx is equal to y. So that means where this y equals 0, which is on the x-axis. So here it equals to 0, here it equals to 0. So I would say that looks to me to be minus 0.75, and then here and 2.75. Okay, and just be careful, I should have mentioned this earlier on, to just look at the graph scaling. So here you can see each square is worth 0.1 as you move to the right, or here minus 0.1 as you move to the left, whereas over here as you go on the y-axis up and down, you can see 0.2 per square. So just be mindful of that. So work out estimate for f 1.5. So x is 1.5. So if we come here, so 1, 2, 3, 4, 5, and then we scroll down, and then we go across, then we'll see that we have minus 2.8. So the next question is, find the value of 81 to the power of minus a half. So because we've got a negative power, what we could do is invert it. So 1 over 81 to the power of a half. Now remember that a power half, so if you have anything power half, it's the same as square root. So that means, what is the square root of 81? It's going to be 1 over 9. Find the value of 64 over 125 to the power of 2 over 3. So the first thing we can do is we can cube root. So let's cube root 64, and that's going to give us 4, because 4 cubed is 64. And then the same thing for 125, cube root, that gives us 5, because of the same logic. 5 cubed is 125. And then remember, we still have to square, so we have 4 over 5 squared, so 16 and 25. Okay, question 13. So the table shows a set of values for x and y. Here's your x, here's your y. Y is inversely proportional to the square of x. Find an equation for y in terms of x. So we know that y is inversely proportional. So it's going to be to the square of x. So when we should recall that whenever something's inversely proportional, then we'll have this this variable k here over a value, and in this case it's the square of x. Okay, so y equals k over x squared, and we can find out what our k is by just subbing in any one of these values. Okay, this let's go with this one. So we say 9 in place for y, k, and then 1 squared. So we get k is 1, so 9 equals k. So therefore, we're going to have 9 over x squared. So that means y equals 9 over x squared. So if we put that in there. Find the positive value of x when y equals 16. Right, so if y equals 16, 9 over x squared. So rearrange. So we multiply by x squared. So we get 16x squared equals 9. And then we divide by 16. And again, we're just rearranging to make x a subject. So we get x squared equals 9 over 16. And then because we have x to the power of 2, we just want x. So we get 3 and 4. Let me write that out more neatly. Okay, question 14. So it says white shapes and black shapes are used in a game. Some of the shapes are circles, all the others are squares. And then it gives you the information here. So there's quite a bit, and what I like to do is I'd like to highlight. So the white shapes to the black shapes is 3 to 7. And then the white circles to the white squares is 4 to 5. And then the black circles to the black squares are 2 to 5. So what fraction shapes are circles? So that's our task here. Okay, so how many shapes do we have? Well, there's a ratio of 3 to 7. So that means that there are 10 parts. So the white have 3 over 10. The black have 7 over 10. So this is shapes. And then we know that there's white circles and there's white squares of 4 to 5. So that means 4 over 9 is the circles. And then 5 over 9 is squares. And then here we have on the third line 2 over 5, 2 to 5. So we have 2 over 7 for the circle and 5 over 7 for the square. So if we want to figure out how many of the shapes are circles, so let's just separate this. So we can multiply 3 over 10 by 4 over 9. This will give us white circles. So that's 12 and 90. And then this is white circles. And here is black circles. So the same thing. So we've got 7 over 10 times by 2 over 7, which gives us 14 over 70. So just using a different color here to differentiate. So this here can be simplified. It can be simplified to 2 over 15. And then likewise 14 over 70 can be simplified to 1 over 5. And then 2 over 15 plus 1 over 5 equals 5 over 15. So if we change that to 3 over 15, and then this can be simplified to 1/3. So our answer is 1/3. Question 15. So a cone has a volume of 98 centimeters cubed. The radius of the cone is 5.13 centimeters. Work out an estimate for the height of the cone. So you have the formula here. Let's zoom in slightly. So I have the formula here for the volume of a cone. So we know that, because we know that it's asking for an estimate, so we can change this to 100 and round this down to 5. So let's use the formula. So volume is equals 100. We have 1/3. It's asking for the radius. Sorry, it's asking for pi. So we know that pi is 3.14. To do decimal places, we can change that to 3. So we put 3 in there, and then our r squared, so 5 squared, and then obviously we are trying to figure out h, so we leave it as that. So these two cancel each other. So I have 100 equals 25h. So if we divide by 25, we get 4 equals h. Therefore, h is 4. Now, because we've estimated, remember this is just an estimate, but for our answer that will do. And depending on how you estimated the value will give you a different answer. I think this is perhaps the most inclined numbers to estimate for, but you might have something else that's also reasonable. For B, will your estimate, so John used a calculator to work out the height of the cone to 2 decimal places. So will your estimate be more than John's answer or less than John's answer? Give your working out. So the answer here will be that the actual, for me personally anyway, the actual height will be lower. The estimate will be more in my case. So let me write that down. So and this will obviously depend on what you've done. So the actual height will, I'll explain why. So I rounded pi and r down. So essentially dividing by smaller number. Okay, so as you can see here, I estimated my r down and my radius down. So when I came to divide by my 5 squared, the number was smaller, and therefore, and also the number here, the volume 100, was rounded up. So if you have a larger number as a numerator and you're dividing by a smaller denominator, the number is going to be much larger, so the actual height will be lower. Question 16. So n is an integer greater than 1. Prove algebraically that n squared minus 2 minus, and then open brackets, n minus 2 close bracket squared is always an even number. So this is just proof. The first thing that we need to do is think about how we can show that something is an even number. Well, we know when we have an even number, it's going to be 2 times n. So anything multiplied by 2 is going to be even. So we want to show, in this particular case, that we're going to have 2 times some x, and we want to essentially derive that form from this expression here. So let's go about thinking how we do that. So n squared minus 2 minus, and I'm going to expand this. So we're going to have n minus 2, n minus 2, and then n squared minus 2, and then if I expand out, I get n squared minus 2n plus 4, and then I get n squared minus 2 minus n squared minus 4n plus 4. So literally all we've done here is we've expanded this and then collected the like terms, and then literally I can open up now this to the other part of the expression. So n squared minus 2 minus n squared plus 4n minus 4. So let's simplify. So that cancels with that. I get 4n minus 6. So now I can see that 4 and 6 are even. I can factor out a 2, which will give me 2n minus 3. So therefore, because there is a 2, that means that this is even.